So let's go ahead and take a look at section 7.3, the notes for logarithmic functions as inverses. So as part of our opening exercise, you worked together in your table groups and you considered a statement something like power 2 of 8 equals 3. And I asked you all just to kind of think about what that might be saying. And as you talked through it, eventually what you had decided was that you looked at the connection between the numbers and you saw that 2 to the third power is equal to 8. So this expression, power 2 of 8 equals 3, must be equivalent to that. And it turns out that that is exactly correct. When we think about exponential statements and an inverse of that exponential statement, which is a logarithm or sometimes called a log, and the term logarithm tends to be very confusing to my students. So I started off by looking at the relationship between the numbers without using the terminology. But a log, one way you can think about it is it's a way to answer a specific question. So log A of B, log base A of B is asking the question, what exponent would be required to go from a base of A in order to reach a value of B? So that log base 2 of 8 is asking me, what exponent can I put on 2 to get a value of 8? So if I asked you, what does log base 3 of 81 mean? Well, what exponent can I put on 3 to get to 81? It's 4. So log base 3 of 81 is 4 because 3 to the fourth power is equal to 81. Log base 4 of 16. Well, that is equal to 2. That's asking me what exponent can I put on 4 to get a value of 16. And how about this one? Log base 5 of 5. What exponent can I put on 5 to get 5? 5 to the first power, right? So log base 5 of 5 would be equal to 1. And once you start to think through it in that way, what exponent can I put on this base to get this number? They'll start to make a little bit more sense. And if you want a map, there's a map that is right up at the top of your notes page. One way you can think about this is the log is the exponent, and the base is always the base, whether you're talking about a log form or an exponential form. So let's go ahead and fill this in. If you have log base b of a equals x, the equivalent exponential form is the base b to the exponent x is equal to a. So the log is the exponent and the base is always the base. So go ahead and copy this into your notes. So let's go ahead and try one. If you look at item number 1 on your notes page, you're asked to write this equation in exponential form. The log base 3 of 9 is equal to 2. So how would you convert that to a log form? So what exponent can I put on the base that gives me this number? 3 to the second power is equal to 9, correct? And even if the conversion between logs and exponents didn't really make sense, I think most of you are able to look at those three numbers and go, well, 3 squared is equal to 9. And that would be correct. Let's try another one now. This is item number 3 on your notes page. Take this expression, the log base 7 of 1 equals 0. And we want to write that in an exponential form. So these are not as obvious as the 3 and the 9 and the 2. So let's fall back on what we know about the conversion between these two. So log base b of a equals x. Log, the base is always the base, 7 of 1 equals 0. So the log is the exponent and the base is always the base. So 7 to the 0 power is equal to 1. Remember, anything raised to the 0 power equals 1. So let's go ahead and type that in. And we find that that's correct. So can we go in the opposite direction? Can we take an exponential expression and rewrite it as a log? And again, we're going to rely on our relationship here. Log base b of a equals x, the same as saying b to the x equals a. The base is always the base. The log is the exponent. So let's see what happens when we look at that. The base is always the base. So I know log base of 14 of 196, and then the log is the exponent. Log base 14 of 196 is equal to 2. And that turns out to be correct. Let's try one more. And this one is going to look a little bit different. This one has a fractional power. 36 to the 1/2 power equals 6. Much unlike 3 squared equals 9, our first example, it's not very easy for us to just simply look at these groups of numbers and see the relationship between them. So let's fall back again on the relationship that we have. Log base b of a equals x, b to the x equals a. So the base is always the base. So this is base 36 of 6, and then the log is the exponent. Log base 36 of 6 equals 1/2. Remember, 1/2 is taking a square root, right? So the square root of 36 is 6. So let's type this one in. We're going to use our log key in the math tool and quizzes. A base of 36 of 6. And let's get outside those parentheses. And then equals 1/2. So again, if that last one felt like it was a little bit challenging, I'm going to share an image that comes to me from one of my favorite math bloggers. And she kind of wrote this using these arrows. So she writes the base of 2 raised to the 3rd power is going to give me this value, which is called the argument. So 2 to the 3rd power equals 8 is the same as saying log base 2 of 8 is equal to 3. So we did some practice together. Now I'd like you to sit in your table groups and begin work on the 7.3 practice handout, logarithmic functions as inverses. And I'll be making my way around the room, peek over shoulders, answer questions, and probably sit with a group or two of you all.